Greetings, Earth and Space Explorers. Welcome to Doc Waller's Earth and Space Report for Friday, December 17, 2021. I'm your host, Bill Waller, an astronomer, science educator, and communicator, coming to you on a cool moonlit evening in Rockport, Massachusetts. These Earth and Space reports are intended to engage and inform people like you who are curious about Earth as a planet, who care about our life-sustaining environment, and who wonder about the greater cosmos, including our place in space and moment in time. Video recordings of these reports are archived on the Earth and Space Reports YouTube channel. They are also in regular rotation on the 1623 Studios Community Access Cable, Channel 12. I am grateful for the continuing interest and support shown by members of the Rockport Research Explorers, Rockport Cultural Council, Gloucester Area Astronomy Club, sundry science colleagues, far-flung friends, family, and other curious folk. Thank you for participating. This evening, I will be hosting an interactive Earth and Space Year in Review. We will start with Dr. Jay Pasachoff of Williams College, who will tell us a bit about his trip to Antarctica, where he witnessed the total solar eclipse that occurred there on December 4. Then I will continue with a summary of what has transpired on Earth over the past year, and then finish up my summary of what has been happening in space, and finish by opening the platform to everybody so that you can share your own stories relating to this past year. So let's get to it. I'm going to move on. I think we're good for Jay. I'm going to unmute you, ask to unmute. You're unmuted. Okay, you're good.
Okay, thank you very much. I'm glad to be visiting my old friend Bill Waller and to brief you on this very interesting total solar eclipse that we had almost a couple of weeks ago. I've got to advance here. Let's see. We're screen sharing, but all right, well, maybe that one works. So here's first of all a picture that we've arranged from the last eclipse I saw, total eclipse I saw, where there was a double diamond ring at the beginning and then a single diamond ring, Bailey's beads at the end last year, 2 years ago in July 2019 from Chile. And then last year in Chile, we couldn't get there and it was cloudy where I would have gone. We are celebrating the 100th anniversary of the 19th. And anyway, there's this odd picture from the Discover satellite that shows the moon blocking the Earth. And does Bill remember Donald Menzel, who's went to so many meetings, developed his doodling skills? So
yeah, I saw him my first days at the Harvard Smithsonian.
So anyway, what we're studying especially are these polar plumes and the equatorial streamers, and we want to see what the eclipse is like. And of course, the total solar eclipse is just off the charts interesting. So here is the eclipse over Antarctica. So here's actually the shadow of the moon falling in Antarctica in this very unusual and remarkable view. Our science goals, I'm going to rush through them, but we're studying the magnetic field, the coronal mass ejections, and we have spectra, and we're looking for how the corona got to be 1 million degrees. And here is a picture that I took from 41,000 feet. I was on an airplane that was over the ocean east of Punta Arenas at the tip of Chile, kind of surrounded by the Southern Ocean Bay near Antarctica, where there were 14 cruise ships, 13 of which were clouded out, which was a good reason not to go on a cruise ship. Here's an image I took. So here was our plan to leave Punta Arenas and fly and get the sunrise point out the window, and then the path of totality went over Union Glacier, and I did have equipment with 2 groups of people here, so we have data from them too, and so we flew out after midnight and a couple hours, and then had a run for the eclipse for just about a couple of minutes, And it was due south of New York. I was amused that we went south the whole way, the compass heading. And anyway, we're at the minimum. We're coming off the minimum of the sunspot cycle now. And I had two students from Williams College with me, and an alumnus who we all worked and flew down to Punta Arenas. And here I am with my traditional orange pants from the plane. We had a LATAM last minute substitution of a 787, which was not helpful compared to the Airbuses, but it had to be done for safety reasons because of the extended range of the 787. So anyway, I had my my students here, and we worked away. Here, my wife Naomi and I are about to board there. So we flew out, and they have to be in exactly the right place at the right time, so I'd make a little loop to loop. And anyway, we got this eventually this good view. Here I am with the captain, the tour organizer. So it was just after sunrise. So I did have some colleagues and students with me, getting a lot of images, and one of the things we were doing is working with people at Predictive Science in San Diego, who make predictions based on the last month of magnetic field data, which they get from the Solar Dynamics Observatory. And if you go to the NASA website here, a couple of days after the eclipse, this is actually a slider where you can see their whole view or our whole view, where we started to reduce our images, and we're matching pretty well what happens there. But they make these predictions in advance, and then when we provide the actual observations, they can improve the predictions for the next time. So this is their full prediction, and you can see the streamers that were predicted in this part of the solar activity cycle. They're just polar plumes. There aren't streamers coming out of the high latitude. This is a logarithmic view of those predictions, and I'll skip over this is a wavelet analysis. So there's a lot going on, magnetic field map. So here is one of our images, our whole images, and you can see some streamers coming out here. And so we continue to work on improving those observations. We do have spectra, and we can see spectral lines from gases, magnetic iron. Here's a clearer view. Iron 14 is 13 times ionized iron, which means it's got to be 1.5 million degrees up there. And the ratio of the lower ionization still very hot, almost 1 million, and the 1.5 million, it gets hotter and hotter as the corona gets hotter in the sunspot cycle. And we had with us Aris Bulgaris from Greece with a couple of spectrographs. So Andreas Muller from Germany was on the same plane, and here's one of his images there as the eclipse ended. And we're working away to compile our own images with all our data. And in particular, there are spacecraft data in the extreme ultraviolet. You can see on the center of the so we paste that over what would otherwise be dark, because that's the corona also. And then you can make, there's a spacecraft that makes an artificial eclipse, but it can't get close to the sun just because this is so bright. It's about 1,000 times, fades about 1,000 times from here to here. So you can't do that all together. And so we have the outer corona from space on the solar and heliospheric observatory. And then only on the days of eclipses, about every 18 months or so, can we fill in the view from the ground. Let me just advance a little bit. So here again is the solar ultraviolet imager, which is on one of the GO spacecraft, and then our eclipse image and how that merges. You see how that streamer merges with the solar and heliospheric observatory. So that's what I have to say. Now it all worked. We were very nervous about all kinds of logistical things and travel and observing but we've got some good imaging and we're going to work on it for quite a while.
Well, thank you, Jay. That's quite a unique. You've gone to how many eclipses now?
Well, 74 solar eclipses,
Yeah.
starting when I was a freshman at Harvard, and this was my 36th total eclipse.
Yeah, that's record making.
So we're watching this. So anyway, thank you for inviting me, Bill. And
Okay.
we'll talk again.
Have fun with your students tonight.
Thank you. Well, yeah, the reason I'm rushing away is I'm giving a review session for the exam they're giving tomorrow, scheduled at the same hour. So thanks everybody who's listening for listening.
Okay, good. Thank
All
you,
right.
Jay. Don't forget to
All right.
unshare your screen.
Okay, I will do that.
There we go.
Okay.
Okay, excellent. So now it's my time. Turn to share my screen. Screen sharing. Okay. And slideshow from the beginning.
Bill, does your mind look like that's your desktop?
Does what?
Does your mind look like that desktop?
Always. It gets much worse, especially when I'm putting something together. Anyway, Jay's presentation is a beautiful blending of Earth and space because we're seeing the sun being blocked out by the moon from Earth's vantage point. But now we will go back to what's going on Earth for the past year. So a lot of what is happening on Earth is just continuing. The Earth continues to spin, once every 24 hours and orbiting around the sun once every 365 days. That's not changing much, certainly over the progress of a year. Maybe over the progress of tens of thousands of years, the Earth's spinning might change and the orbit might change a little bit and its tilt might change a little bit. But those two basic properties of Earth are pretty much constant. But there are strange churnings lurking in its interior, and this is just a model, a cartoon, showing the solid inner core of iron and nickel, surrounded by the molten outer core of iron and nickel. And it's the swirling currents in the molten component that is thought to produce the magnetic field of Earth. And that does change. And as we can see, the magnetic field has been, let me change, what do we want? I just want speaker. There we go. Okay. So for some reason we have Michael, but anyway, this is the magnetic field strength. And it was high in 1700 and it has been continuing to decline over a long period of time, of centuries. And it brings up the possibility that the field might go to zero, to basically a scrambled field, and then possibly reverse itself. There have been field reversals in the distant past. And so that's a possibility left open. But it's controversial, we don't know. Meanwhile, the North Magnetic Pole has been wandering since the 1600s and 1700s. That was when way down here at 70-degree latitude in Canada. And it has been wandering ever since, such that it's up around here. And it now has a latitude of 86 degrees, not quite the pole of the spin axis, but it does seem to wander around. So that's been going on. Okay, earthquakes. The mantle, the molten part of the mantle, or shall we say the pliable part of the mantle, has currents, and that causes the tectonic plates to move around. And those plates butt up against each other in certain places, and those produce earthquakes from time to time. And these were the largest 20 earthquakes this past year. And I want to bring to your attention this strong one near Antarctica, an 8.1 magnitude, one in the Aleutian Islands in Alaska, and then one in Chile. That was the deadliest one. It's not as strong, but that had more than 2,000 fatalities as a result. And that it also brings up a point that sometimes these earthquakes are aftershocks of prior earthquakes. There was a huge earthquake. I don't remember the year, but it was in the 2000s, which really devastated Haiti, and it really hasn't recovered since. There's also one in, is this Indonesia? Yeah, 7.1. And I think that's the Sulawesi earthquake. And this is the sort of damage that it can cause. Sulawesi, Indonesia. And this is a governor's office building that was just completely destroyed by the temblor. All right, volcanoes. Volcanoes are continuing to be active. Like the earthquakes, they tend to be associated with tectonic plates, which are butting up against one another, usually in subduction zones. One plate's going underneath another one. And I want to bring your attention to La Palma, which has been erupting quite a bit. It prevented a colleague of mine from going to a conference there. And I'll show you a picture of Mount Etna, which is reviving as well. Kilauea in Hawaii is also erupting. And there are several volcanoes in the area of Indonesia. And I think there was a recent eruption in Semeru. I'm not really sure. The Earth continues to be active. Here is a very recent photograph, December 14, of Mount Etna in Sicily. And so that prevented travel and gathering on that island of Sicily near Italy. And then there are the forest fires across the globe. Because of the parched areas, there was a lot of heat in all across the globe. And July seemed to be an especially hot month. It's the hottest month ever recorded, with some places exceeding 120 degrees Fahrenheit. And you can see that there were a lot of forest fires in California and British Columbia. I'll point them out, but also a fair bit in the southeast the United States, as in South America and Africa, kind of like below the wettest areas. Australia had its fiercest forest fires last year, but it was still alight with forest fires. And then, oh yes, the Siberia has been lit up with a lot of forest fires. And where there's fire, there's smoke. And here's North America, and you can spot some of these fires. This one is in British Columbia, but also Washington and Oregon had fires, as well as in California once again, and in the Tahoe area right here. And some of the smoke made its way, courtesy of the jet stream, at stratospheric altitudes all the way to the Northeast in Massachusetts, where I live. And we had some very hazy days this past summer. And the result of forest fires is that they remove foliage along with the root systems, and that exposes the land to flooding if you get rain, and even landslides. And this shows the incidences of flooding across the world. And Europe and the Netherlands and in Germany really got hit hard, as did China. Where's China? China over here, and I'll just show you some photos from there. I think Australia did too, but they don't seem to have a number there. So, okay. So here are the Netherlands, flooding in the Netherlands. And I'm not sure whether this is the Netherlands or Germany, but obviously there was a big landslide here. And here's a major metropolitan district in China, inundated due to the flooding at higher altitudes. Okay, so that's all the fun we've been having. A lot of it can be attributed to global warming and the addition of energy to the atmosphere. But there's also atmospheric phenomena which can be attributed to the La Nina event, which has kicked in. And this is La Nina lasts about 3 to 5 years. It's the opposite of El Nino. With La Nina, you get a cooling off of Peru in the Pacific Ocean, and that cooling changes the circulation patterns and the jet streams and the corresponding weather. And here is what is predicted for the United States with the jet stream like so. You have colder weather in the upper Midwest, wet weather in California, Northern California, and Oregon and Washington and British Columbia. So that should be helpful with regard to the fires, though you might get more flooding. The Southwest will be drier and the Southeast will be drier. And so that just is going to add to the drought that the Southwest has been experiencing for several years now. We here in the Northeast seem to be getting wetter. Not good for amateur astronomy. And so I don't know whether the La Nina affects the hurricane season. It seems to have been a busy hurricane season, third most active, with 12 named storms, 5 hurricanes, and 3 major hurricanes. I guess those are category 4 and 5. And based on the color code, it looks like Ida and Grace had the highest winds. And I'm not really sure which ones had the greatest amount of damage. As I recall, those were the ones that hit Louisiana. And putting a face on a name, you can see that several of these hurricanes had eyes. Ida had a well-developed eye, along with, where's the other one? I don't know the name of this one. I can't see that. So I'm going to move on to the typhoon season, which are basically hurricanes in the Pacific, the West Pacific. And they had several category 4 and 5 storms. And I think most of the damage occurred near the Philippines. You can see this one got to be some pretty high wind velocities. And in addition to hurricanes, tornadoes, which are smaller but more intense with higher wind velocities, there's an estimate of about 1,100 tornadoes that occurred in the United States, including twisters in both the Midwest and the Southeast. And this one's a hard one to read, annual count. They talk about inflation-adjusted tornado trend, but it looks like they're following this black line. This is the line, and this is an accumulation plot of the number of tornadoes. And you can see that the slope is high from April through July, but then it starts to flatten out with fewer and fewer tornadoes. But we just had a big tornado in Mayfield, Kentucky, and elsewhere in the Kentucky and Tennessee and Missouri, including a tornado that has had the longest track ever, 250 miles. And this before and after just is stunning with the candle factory before and then after. It's just obliterated, as was this other building here. These tornadoes can really shred buildings. Meanwhile, there was a major summit in November. World leaders, scientists, and activists, they gathered in Glasgow, Scotland for the 26th UN Climate Summit. And you might recognize this fellow, Boris Johnson, and this fellow, I can't remember his name, but he is a major author and TV personality.
David Attenborough.
Say it again. David Attenborough. Thank you. That's right. And Boris Johnson really set the stage as the host in the UK, as basically a now or never to try to keep the global temperature down to 1.5 degrees, the change in temperature. And I liked what Joe Biden said. We know what to do. We've just got to do it. So against this backdrop, we all await policy changes that will make it happen. Of course, our climate is driven by the sun, and we are just tweaking it by adding photochemical gases in our atmosphere. So daytime and much of the nighttime is ruled by the sun, and it has finally begun to awake from its magnetic slumber. As Jay Pasachoff said, there are now sunspots. This is a very recent showing of sunspots. I think it was December 14th or so, very recent. And then this is an H alpha image of the sun showing the active regions where the sunspots are and the magnetic loops between the poles of the sunspots. There's also prominences jutting out from the surface of the sun, and filaments, which are basically prominences seen against the face of the sun. And so we're starting to get some activity. It has been a long, low period in the 11-year cycle. And so we now have something to look at. This is good for people with solar telescopes. And then getting back to Jay's eclipse that occurred December 4, passed over the Antarctic continent. And so that would be summertime in the Antarctic. And so this is the land of the midnight sun right now. And you can see that even at midnight, the sun is above the horizon. And I don't know which way it goes. Maybe it goes this way. And then sometime around midday, they had the eclipse. And pretty neat. The nighttime sky. Nighttime sky has stuff which can be attributed to our atmosphere, thunderstorms, of course, in the troposphere. And above the thunderstorms, once they get up a little bit higher, like the superstorms, they can produce these sprites. It's a sprite phenomenon. I don't know anything about the blue jet phenomenon, but there are sprites, steves, and aurorae at even higher altitudes, between 100 and 200 kilometer altitudes. And the neat thing is they're being recorded with ever greater fidelity. And as an example, I'm going to show this brief video. Okay, here we go. So at 100,000 frames per second. So here's the sprite, the actual color. It glows in the light of excited atomic oxygen. And away we go. So it's fascinating to see the discrete nature of these of these events, that they're little balls of excited oxygen gas, which, and I don't know what the excitation mechanism, it's something to do with the storms, the thunderstorms. So that's where the electrons are coming to bombard the oxygen and get it excited. Also, at even higher altitudes, we're dealing now with constellations of satellites, which are marring astronomers' long exposure images of the cosmos. And here is basically a network of constellation of satellites. I think this is for Amazon, I'm not really sure, but you can see that it's starting to number in the thousands. And this is what they do to long exposure images of the cosmos. Here we have some background galaxies, and these are the streaks, which are really making observing from the ground at optical wavelengths problematic. And I'm just hoping that these private companies will be reined in with some decent policies. Moving farther out, we did have a comet. We do have a comet. It's just coming into the daytime sky here in the northern hemisphere. It's called Comet Leonard, and I haven't seen it myself yet, but this is a lovely photo that was taken by Dan Bartlett and shown in the astronomy picture of the day. And here it's upstaging the Globular Cluster M3, which is another 30,000 light years away. So this is a relatively nearby object, which is just a few light hours away, or less, a few light minutes away. And here's an artist's conception of the night sky. We have a lovely lineup right now of planets, beginning with Venus, and then moving on to Saturn, Jupiter, the asteroid Pallas, Neptune, the moon. Actually, the moon is way over to the left right now in a near full phase, Uranus, and another asteroid series. I don't have much to say about these planets. Venus, the latest news is that the claim of phosphine in its atmosphere. This is an interesting compound because on Earth it's associated with life, mostly rotting, stinking life. And so they think, oh, wow, phosphine in the atmosphere of Venus might indicate some sort of life processes going on. However, that detection has not been confirmed well. It's basically one spectral line in the radio. Saturn has plans to go to Titan with a satellite that will investigate the Titan terrain in a really neat way. I can't remember the name. It's not Grasshopper, is it? Well, jumping to Jupiter, the Jove satellite has an orbit that goes over the poles, and it's showing fabulous pictures of the atmosphere of Jupiter. Neptune can only be spotted with a telescope, and Uranus possibly with binoculars, though I haven't had much luck. All right. Ceres and Pallas. I think Pallas has been visited by a spacecraft, and we might be getting yet another sample return soon from another asteroid. This is a fun thing. More than 400 years ago, people like Galileo were sketching the moon based on observations through the telescopes that they had available at the time. These are Galileo's sketches. And that tradition continues today with sketches by Dick Lukey. And in order to get to that, I'm going to go to his gallery and close. And you can see he was busy in 2020 and 2021. And we'll start here. Well, maybe here. I don't know if that's does that count for 2020? I'm not sure. But we'll go to this shows the terminator, the night day switch from nighttime to daytime on the moon, and that was in March. And he shows these various craters. And I don't know what crater this is. Dick is at a concert tonight, so he can't tell me. But this is on a black paper, and now he's using white crayon. I think this works out rather nicely. And this is the Copernicus crater, one of the larger craters on the moon, and he's showing some of the details of the rim. And apparently the middle of the crater is filled with material that has a different shading than the outside of the moon, due to stuff that probably upwelled. And oops, yep, this is the last one, crater Julius Caesar. And here he's using a gray background, which he enables him to use both black and white. So I encourage those of you who like to draw to try your hand at sketching the moon. Okay, so I am done with Dick. All right. Other amateur astronomers do astrophotography, and they are getting better and better. The equipment's getting better and better in 2021, and the software for processing the images is just getting better and better. And this example from Phil Urbanes, a member of the Gloucester Area Astronomy Club, pretty much exemplifies what can be done with a telescope of rather modest aperture, but with a good camera and filters and post-processing. So you see, for example, this is the Orion Nebula, and the something man nebula, the Walking Man Nebula, and this is M101, and this is which is fabulous, and all the red things are brilliant star forming regions. Here's M51, the Whirlpool Galaxy, which is an interacting galaxy, and then I believe this is M83, a barred spiral galaxy, again with beautiful roseate regions due to intense star formation. Okay. So moving way out past these galaxies, I want to highlight the Chime Radio Observatory in British Columbia, as it just released its first large set of data on these so-called fast radio bursts, FRBs. They are a great mystery because they, occur anywhere in the sky, and they occur very briefly, and they often do not repeat, and so it's hard to get a handle on them. There are a few FRBs that have been matched up with galaxies, very distant galaxies. So we believe that they are extragalactic, meaning they are beyond our Milky Way galaxy. And the neat thing about this telescope is that it really is a wonderful FRB discovery machine, because with these cylindrical collectors, they have a beam on the sky, which is this big oblong beam. And so they can scan the sky, which is shown here, very efficiently. And then they use software to pin down where along this beam the source occurred. And so they're able to locate the source in the sky to high precision. And the output is basically frequency dependent, that the bursts last a very short amount of time. I believe this axis is the time axis, and that's in milliseconds. And you can see that dependent on the frequency, the profile of the burst in time can change. And that is called, that produces dispersion. Excuse me. And the measure of that is called the dispersion measure. How much the the pulse changes with frequency. And they basically integrate this plot over time, and that gives you a measure of how much the signal has been messed with. And it gets messed with by free electrons along the line of sight. Those free electrons, in the case of pulsars in our own galaxy, are due to material in our galaxy, free electrons in our galaxy. And you can see that the dispersion measures are on the order of 100 to 200 or so. But as studied by Jerry Zhu at the Cape Fear Academy, who I had the privilege of mentoring, the dispersion measures are much higher, on the order of 500 to 600. Some people say that's because these objects are very far away and the intergalactic medium, you know, the travel through the intergalactic medium is having its effect with the free electrons in the intergalactic medium. But just as possible, it could be that these objects are embedded inside their own nebulae. And the possibility is that we're looking at magnetars, highly magnetized erupting stellar systems, which are surrounded by their own nebulae, just like pulsars are surrounded by supernova remnants. And of course, the cord is out on this, but this is a very, I find a very interesting finding that Jerry Zhu was able to show. So that's basically the science for today. Moving on, the James Webb Space Telescope, we're all waiting for its launch, and I just checked, it's scheduled for Christmas Eve, December 24. This is a big telescope, a 6.5 meter diameter telescope. Compare that with the 2.4 meter telescope, 2.4 meter diameter telescope of the Hubble Space Telescope. And this is going to be big. It's going to be operating in the infrared mostly, but it's going to peer farther back in space-time to the dark ages to reveal galaxies that are just forming in the cosmos. And then also will reveal basically the environments of planets in formation around other stars, and some fully mature planets. There's a chance that it might be able to see some planets around stars. And it also, it's a big light bucket, and so the spectra that it gathers will also give us important information on planets that happen to be transiting in front of their stars. So it's a very exciting telescope. And so this is it. What Earth and space happenings have been engaging you the past 12 months, or have engaged you in the past 12 months? And so I ask that you use the chat to enter your name, and I will call on you in sequence. So I will stop sharing my screen. Stop sharing my screen, and we'll have at it. Splendid. Thank you, Bill. So if we don't have any folks who want to speak, Mike, do you want to show your telescope?
I said sure, but I was muted.
Okay. Oh, I got to unmute everybody. And so that's under participants.
We can unmute ourselves.
Okay. Good. Oh, there it
Yeah,
is.
so anyway, there was that. Let me see if that works. Just to show off, really, that's all it is.
Oh,
It's
yeah.
a beautiful thing.
It's a beautiful thing. Do you want to name the guy's name? Give that guy's name? Shout out?
Yeah, Ryan Goodson. He's in Dinwiddie, Virginia, and that's his company, New Moon Telescopes. He's meeting me in Connecticut with the scope. That's black walnut and carbon fiber with a very lightweight secondary cage. The 4.1 inch secondary, I couldn't believe how much it cost me for a secondary mirror, more than my first telescope.
Is it just a flat?
It's a 45-degree flat, yeah.
Yeah. Yeah, this is going to be
500
beautiful.
bucks
for the secondary, which is up
for
here.
the secondary. Yeah.
Yeah, that's impressive.
But it's cool that the trusses are all one piece, one big folding finger handcuff piece. It collapses down instead of individual tubes, which makes putting the secondary cage on that much easier. So we've all seen enough of that. Hang on.
Okay. Yeah, that's a sweet, sweet scope. Well, I remember views through your 18-inch, Michael, views of Mars in 2006 when it was
That last
extremely
really
close.
good apparition that we had back
was
a few years
amazing.
now.
I felt like I was just floating above the Martian surface. It was just fabulous.
This should put you on the Martian surface. This is the best 20-inch primary mirror money will buy,
God damn.
period.
Yeah.
So
Well,
the
don't-
reason I got a 20 when I already had an 18 f5 is that I'm going to be 70 years old next year. And I wanted to trim some bulk and weight away from my telescope without sacrificing aperture.
Mm-hmm.
So instead of the structure of the thing with the mirror box and the rocker box being made out of thick plywood, which most of them are,
Mhm.
this is made out of hardwood sheets. And it's very lightweight. And the mirror itself only weighs 30 pounds. It's a 20-inch mirror and it weighs 30 pounds.
And you can haul it like a wheelbarrow.
I don't intend to haul it like a wheelbarrow. I intend to pick it up and walk out into the field and put it down on my equatorial table. When I'm done, pick it up, go back to the van, put it in the van. So I could do that when I was 20. Why can't I do it now? But that's the plan. I want to
Let
be
me
able to
count
use
the
the
ways.
big scope until, I'm 80. And that's was my best guess at it.
Cool. That's really cool. And while we hope to see you at star parties at Halibut Point State Park that you've managed to secure once again. And of course, we'll do our guerrilla astronomy around Gloucester and Rockport, perhaps on New Year's Eve.
Perhaps on New Year's Eve down by Dock Square.
Right.
We have insurance now, $1 million liability.
Okay. So.
Yeah. So you can trip people as they walk by. It won't matter.
So I'm going to ask Paul, what's new in the ham world? Have you been able to? What are the atmospheric conditions that you've experienced? You'll have to unmute, Paul.
Yeah, no. Well, of course, the big thing is,
Oh, you're not coming in well, Paul. I'm gonna shut you down.
Tim is laid mini course tonight.
Yeah, that's too bad.
You hear me now? Can you hear me now?
I'll
Can you hear
try
me
you
now,
again.
Bill?
Yeah, you're better now. Hold on.
All right, I'll get closer to the machine too.
Okay.
That might make a difference. Well, the big thing basically is the return of a cycle 25 or the start of 25.
That's
I
the
just
solar
noticed-
cycle?
Solar cycle, yeah. I just noticed that within the last hour, they're running a solar flux of 101 at the 0 hour Greenwich Mean Time update. So that's pretty high. I didn't check the solar wind,
Yeah.
but the sun's starting to get a little more active, which for hams is good, as long as you don't start having a lot of solar flares, of which there was one earlier today. They can knock out the day side pretty badly. Tamath is right now, Tamath Cove, it was a WX6SWW, has extensive, what she calls space weather seminars, mini courses on YouTube, and you can watch them. And so her argument is that the Earth's ionosphere and so on is incredibly complex, and it's virtually impossible at this point to predict it. So anybody want to get really involved in that, they can do it. But solar cycle 25 will dominate what happens in ham radio, because when it was dead last year, it was dead.
Yeah.
And now
Is the major reason for it getting better with
See, they're
the
talking
more
a lot.
active sun?
I didn't want to know something too. You didn't mention something. Yes, of course, yeah. What's happening is you're getting more activity and it's sending more ionization to Earth, okay? That's actually not so bad because during the low ionization period, the minimums, we get a lot more cosmic rays. But when the ionosphere is ionized, it rejects a lot of the cosmic rays. Of course, you get things like the Carrington event in 1859, which was where a telegraph wires acted as antennas and they burned down telegraph offices and things like that. Probably a lot of you know that in March of 1989, that was in 1859, by the way, the Carrington thing. In March of, and I remember this, March of 89, the Quebec power line went down during a storm. What is emerging now, since the cycle is starting up again, is that the, and I'm just realizing this from listening to her, that the GPS is going to be affected or is affected by the solar weather.
Mm.
And most of these satellites, at least the ham ones, but a lot of like sensing satellites for the Earth are small, low Earth orbit satellites. And the Earth's atmosphere expands when we get hit by like a coronal mass ejection. And that creates more dynamic drag on the satellites. So all of these little satellites, including the GPS ones, kind of could get knocked off their position, which is not too good for a GPS satellite. But I think you're going to start hearing more of this as it goes along. There's a lot of people out there freaking out about it, but that's about it from the, that's most of the science. You know, to mention, and I will, that this is the
Okay, you're breaking up again, Paul.
18th
Breaking up, Paul.
was
I'm gonna mute you again.
like,
Sorry.
okay, I'm all done anyway, Bill.
Okay, good.
Okay, I
That
am
was
all
good.
done.
Thank you. Bill Wall, are you still there?
I'm doing pretty well. How are you doing?
Oh, I gotta.
Yep.
I gotta mute him.
What's up?
Okay. So although you've recently retired from your work at the Astronomical Institute in Mexico, are you following anything of late?
What I've been involved in an astronomy club, as a matter of fact, the amateur astronomy club. It's the Royal Astronomical Society of Canada, and there's a Vancouver chapter here. And actually, I could maybe I should share the screen because there's something I've been involved with that.
Cool.
I'm not going to take too much time. I realize time's nearly up, but I mean, I'm going to just show a couple photos of what I've been trying to do.
Great.
Let's see, share the screen. Okay, here.
And these clubs are
You see
all
that?
available to the public, right?
Yep, we're a charitable organization, and my idea was that we should get. You can see in the photo here, this is a 6-meter dome. It's a portable planetarium, and I proposed to the club that we buy one of these and give shows not just to the public but to our own club members. And it doesn't even have to be shows. Like, I mean, as you can see in the background, the clouds are very common here. So if we can't have starry nights where you can see the actual sky, you can actually see a virtual sky, and you can teach the public as well as our own members, or just have, this is what the sky looks like right now, and you can just enjoy that. And we could also do simulations of light pollution And we can see what the sky would look like with and without light pollution and what proper lighting can do. We can have cultural shows. We're trying to get First Nations peoples involved. That's turning out to be very difficult, but we might actually succeed. So you get an idea of the size of the dome here. The council, our club, is not very enthusiastic about this at the moment because of the price tag, but we're a dedicated group of us are still working on this, and we may eventually succeed. See, this is a very simple dome from Digitalis. This is from Bremerton, Washington. They're just south of the border from us. Just showing the computer system. Yeah, this is on the inside. The pictures aren't great on the inside because
The presenter can
exposure.
stand?
The presenter can what?
Stand?
Oh, everyone can stand. I mean, it's huge in there. So it's, and you can have chairs in there if you want. We were sitting on the floor, most of us, but some of us had chairs.
I know kids
And,
really love crawling into the chamber
Oh, yeah.
and experiencing it on the floor.
I mean, that's one of the things we want to do with this is not, we're going to be mostly for our own club members at the beginning, right? Was we learn how to use it and show this is the night sky on a starry night. So even if the sky is clear, you can say, this is what the sky looks like. Here are the constellations, so you can orient yourself. So this is, I think, a great idea. But we also want to take this to schools, public schools.
Sure.
And we can give them shows for free because we're a charitable organization. So we have to do it for free. And we believe there'll be a great demand there. We're going to be in touch with teachers and see what they say. But that's a projector. And here's this particular, I think this particular movie was interesting. Yeah, I can show one of the movies here, which is very short, but let's see. What I'm showing is how quickly you can disassemble one of these.
But,
The flourish at the end, yes.
you do need a big room.
That's the one drawback. You do need a big room. You need a room with, see, that's 3.7 meters high, so like 11 feet. So you need a high ceiling, fairly big room. Yeah. And then he's folding up after this. So, but yeah, that was a demo that we went to, and it impressed me. It was a great view. It's not quite as good as analog as far as the stars appear, not point-like stars. They're like spots, but they're still quite good. And the sky was nice and dark between the stars. So it was, and you can do, because it's digital, you can do almost anything, show almost anything with it, flying to the planets, flying out of the galaxy and so on. So I think this is maybe a good, it would make a good talk for your club. I mean, for your Earth and Space report, maybe I could talk about the progress I've made with this, like in a year or something, if I've made progress.
That would be wonderful.
Yeah, because your club might find it interesting. I mean, our club is very big. We have like 300 members, and we have a big legacy fund and so on. But you know, this is something. If a number of clubs got together, you could maybe get one of your own. It could be quite useful. You know.
Well, what is the price tag?
Yeah, that's the problem. This, including the projector and the software and the dome and everything, is going to be, let's see, in American dollars, is like $53,000.
I know that the Rockport schools, at the least, make use of a portable planetarium. I think they used to get it from the Museum of Science in Boston. They would come by and host the show for the kids in the auditorium or in the maybe in the gymnasium. And so it's something that some teachers have some experience with.
Yeah, and we have teachers in our club, as a matter of fact. So we're going to approach them and see if they're interested, because they could actually give the shows themselves. So I think they're going to be this could be really good for our club as well as for the area, for schools as well.
Okay, it's been basically a perfect hour, and so I'm going to thank you, Bill and Michael and Paul.
Thank you.
And Jay Pasachoff for giving us updates on what's been going on this past year. And so I wish you a wonderful next year, 2022. fun holidays and good food. And may we all enjoy less COVID in next year. So anything else, Michael? Bill, are we all good?
Yeah, there's one question. Let's see, what club is running the planetarium thing? We're not running anything just yet. We hope to get it. It's the RASC, Royal Astronomical Society of Canada, the Vancouver chapter. There's enthusiasm in our club, so we might end up getting it despite what the council's saying right now. So
I wish you good luck and encourage.
thanks.
All right. Thank you all. I call this meeting closed. Thank you. Bye-bye.
Happy holidays, everyone.